Okay, I want to get into the critique. We've got 7 or 8 minutes left. So there's been this critique, and as I mentioned, a number of the authors on the critique are actually folks whose studies we ended up critiquing or reanalyzing, and then there are others, I think, who just joined in because they had a different perspective. They claim maybe there's lots of publication bias. I just showed you that maybe there's some, but it's not like the slope is zero. I mean, there's clearly some upward sloping relationship. They also were critical about the fact that we didn't consistently focus on lagged effects. Basically, in our meta-analysis, we focused on whatever specification the original authors did. Sometimes they focused on contemporaneous, sometimes lagged. Sometimes they focused on lagged because this was an area with a strong agricultural cycle, so they thought lagged rainfall was most important, whatever. There's a little bit of an economist versus political scientist divide, a little bit here, where I think some of the political scientists leading this effort, including Buhag himself, feel like we're combining things that are too different to be combined. That's kind of like a fundamental point. And they keep coming back to it, and they're like, no, you just can't combine civil war in Africa with communal riots in India. Okay, so we actually wrote up a response, and I just want to go through it quickly. So one thing that we did, and actually we did this before I was even fully familiar with Rosenthal and the file drawer problem, we took the most negative estimate among all the existing estimates. If you add 1, what'll it do to our estimated effect? If you add 2, if you add 3, if you add 4. So if we missed half the literature, so instead of there being, say, 25 or 30 studies, there are really 50 or 60, and we missed half, and they're all really negative, like the most negative study in the whole literature, that would take us to about here on the graph. So the resulting meta-analysis estimate would still be really positive and significant. So looking at the most negative study, you would need something like 80 missing studies. So basically it would have to be like 4 missing studies or 3 missing studies for every existing study to basically have a non-significant effect. And to knock it all the way down to 0, of course, you need a ton. So our idea here wasn't like, anything more than to say, like, even if there are a dozen missing studies, we'll be okay. Now, we don't know how many missing studies there are. This can't really be definitive evidence. Maybe there really are 50 missing studies. Maybe 50 people did analyses they never published. We don't know. They do another thing, and this is also where meta-analysis can be tricky. They said, okay, now we're going to redo your meta-analysis, but we're going to ignore all the current year and current month estimates. We're only going to look at lags. We said, look, we can look at lags. They also said, maybe certain authors are cherry-picking temperature versus precipitation. So we said, look, we're going to kind of do what we did before for specification, and we're going to do it for explanatory variables. Everywhere we can, we're going to look at temperature and precipitation, current and lagged, and create the sort of combined meta-analysis result. So we do that, and we say, look, the contemporaneous temperature effect really is much bigger than the lagged effect. Like, there's a reason for doing it. But there's also a combined effect. Like, maybe there is some persistence. Same thing for precipitation. This is the intergroup conflict on the left. Same thing for interpersonal on the right. There really is a contemporaneous effect to these things. But if you want to look at the combined effect, you can, and we do that. So what we present here is a variety of specifications that different people could prefer. So we've kind of gone down this road in the meta-analysis of doing like lots of meta-analyses using different conditions. Sometimes it's what the author preferred. This has the largest sample. Sometimes we break it down for temperature, precipitation where we can, and we produce the relevant mu's and tau's for all these cases. So for whatever reason someone really cares about one of these estimates, they can go and find it, basically. That was the goal. So again, this says maybe Buhag et al. Have a point on one dimension in saying, like, these studies are kind of different. There is a lot of variability in estimates across studies. But instead of us rejecting a whole literature or the whole approach, our answer to them is to say, well, let's study that heterogeneity. Like, let's try to understand where these differences in estimates are coming from. That's a really interesting social science question that wouldn't have been clarified if we hadn't pooled the literature to begin with. There's another argument they make, and this is a statistical argument. This made us scratch our heads, and I think it's just, again, when you're working in an area that's an interdisciplinary area, with lots of folks with lots of different backgrounds floating around making lots of different arguments, it's actually kind of confusing. So their claim was they reject the meta-analysis approach, basically, because they don't think the studies can be compared. So they said, we're going to reject the meta-analysis approach. What we think is appropriate is you should look across the full distribution of the beta hats and look at the 95% distribution of the beta hats. They would say these results are so different, there's so much heterogeneity in the estimates that if you really want to get a sense of whether there's a meaningful effect, look at the distribution of the beta hats. Don't pool the data at all. So it's like a complete rejection of there being a mu. Remember there was mu and tau? Like they're all about tau. Like all they care about is that spread across estimates, but they're basically imposing no common effect. So like we're going to ignore the meta-analysis. What we think matters is the sort of distribution of the beta hats. Now, this is a very problematic approach because it's data invariant. So if you get more data and more studies with the same distribution, but again, more and more studies that have like an average effect over here. Like you could have 20 times more studies, but with the same broad distribution, they would still have the same confidence interval. So this kind of approach just goes against what we usually think of as standard statistical perspective.